Hi guys, today we're looking at piecewise functions, which is chapter 5e out of the textbook. I've got some questions over on the side here. Oh, my fingers disappear here. All right, but what we're going to do is we're going to look at how to do these graphs on our CAS calculator so that we can visualize them, and hopefully from there be able to do some work with them. So what we need to do is we need to go into graphs and table. I'm going to quickly reset my window here because it is all funky from doing some general maths work. So what we need to do these piecewise functions, what we need to do is we need to, on our keyboard, our CAS keyboard obviously, what we can do is on Math 3, a button that creates this. All right. And what this does is it allows you to define a function for a particular range. So in the case of this first question here, h of x, where x is x, as long as x is greater than or equal to 0. However, when x is less than 0, it is instead negative x. So if I hit enter on that and I draw that graph, you get something that looks like this. All right, it is one graph that may have multiple pieces, but it is one continuous graph. All right, so if I were to trace it, as soon as I hit 0, I switch over to the other one automatically. It's one smooth equation. So what you otherwise, if they don't join up, then otherwise you can end up with things like this, for example. There's a gap there. As you can see there, there's now a gap. So being aware of where these graphs are and how they connect together is useful when you're drawing these. So for example, if I look at one of the later ones, so if I go down to this one down here, there are 3 pieces. It's now in 3 pieces. So on the keyboard, I press that button twice. It's found under Math 3. It's the 4th column, 3rd one down. So if I press that, I add extra rows to my piecewise function. So I go in here. So I have 2x over 3 plus 3 as long as x is less than 0. I have x plus 3 for 0 is less than x is less than 1. And then I have minus 2x plus 6 as long as x is greater than 1. And then I draw this graph as well. And as you can see, it starts out x is less than 0. So it starts out on this slope, then it hits 0 and changes over to x plus 3. It goes up for 1 and then it changes again and keeps going down. But that is one contiguous function for the purposes of our CAS calculator. All right, no mucking around needed, no changing graphs, no making things appear or disappear. All right. Now, when it asks us about the range for these graphs, you have to take into account the maximum values that appear. So in the case of the blue graph, where does the range finish, or where does the range start? What is the lowest value of y on this graph? and what is the maximum possible value for y on this graph. So it's infinity. So if I were to type that out, what might it look like? Am I going to use open brackets, or am I going to use square brackets or circle brackets? All right, I'm going to use square to start with, but because it's infinity, I end it with a curved bracket. All right. So, excellent, good start. Now checking. Oh, by the way, for 0 to infinity, what's another way of representing that? How are in there with r plus, correct. All right, now, if we look at the next function that I've got here, what is the lowest possible value of y for the range? What is the lowest possible value of y for the range on this piecewise function? It's not r minus, it is negative infinity. And what is the highest possible value for the range on this graph? 4. Now, in the case of Hawa, your suggestion of r minus, that would only work if the graph stopped at 0. All right, but because it goes up into 4, we can't use it. So if we were to write this out, we would write it as circle bracket, negative infinity, comma, 4, close bracket. All right. So when you are doing these, you need to be drawing these in your books. The trick is to remember you are only drawing between certain things. And in most cases, these graphs should connect to each other. All right, they should connect to each other. So that's what we have to remember. Now, they won't always, but for most of our purposes for using these for modeling behaviors, they do connect. All right, and remember, these piecewise functions should be actual functions, and they should be, they will sometimes fail the one-to-one test, so the horizontal line test, but they should pass the vertical line test with no gaps.